Okay, so welcome back. Now today we're going to start a maybe 2 or 3 part series where we're going to develop this real world application using C#, Windows Forms. And if you look at it, you can see it's got the date, it's got the time, and that's being updated every second. And it's got outside temperature, this is in Fahrenheit, and it's got inside temperature in Fahrenheit. And it's going to be a little application you can keep on your desktop and give you an indication of time and temperature. So why would we need this? Well, I did this for a couple reasons. Right now, as I record this, as you can see, it's August, it's summertime, and it's kind of nice to have, at a glance, see what the outside temperature is compared to the inside temperature. So you can maybe start thinking about opening the windows and letting the breeze come through and cool things down. But the main driver for this was to be able to measure indoor temperature over time and also chart it. And why would I care about that? Well, part of it was to address one of the many beliefs and intuitive beliefs that surround computer technology that you see on the internet, where people believe that their computer, their GPU and all that is really high power, it's a beast. Therefore, it uses incredible amounts of power and is going to heat up your room, and it's going to get 100 degrees inside your room. You're going to have to turn on the air conditioner. And if you've ever followed any tech forums on the internet, you know that people tend to exaggerate, and honestly they enjoy high-powered stuff and flashing lights, so they tend to exaggerate based on intuition and emotion, but they don't really look at the data. So I prefer to actually look at data. So I felt this would be a good way to actually measure in real time the inside temperatures and be able to chart those so you can see actually what's going to happen if you run, say, your GPUs at full, what's going to happen to the indoor temperatures. And here's an example of what I found in just one situation. And what I was doing is I was running 2 GPUs, an RTX 2070 Super, which is rated 215 watts, and a 1080 Ti, which is 250 watts. And I noticed that their actual power draw was quite a bit less than that. And I know people like to exaggerate, but they don't realize that the actual draw depends on the software, and it's very complex, and you're probably not going to use that entire amount of power. And therefore, the temperature rise might not be really as much as you might think. And here's an example over, I think, like a 3-hour period of what I got from this application by measuring every 5 minutes or so and charting it over time, so you can see actually what the numbers are. So what we're going to do is we are going to build this, and as you can imagine, there's a number of things we're going to have to consider when you think about this in order to develop this. So what I'm going to start out with, we're going to do a little bit of design work first. Because in the real world, if you're an engineer like I am, you know that you don't do a project without designing it first, because guaranteed, if you just jump in, and in this case, if you just start coding, you're going to make a mistake and say, oh, shoot, I forgot about this. You're going to have to start from scratch and redo it and waste a lot of time. So what we're going to do is we're going to spend a few minutes and think about what we need to do to get this data and to chart it, and then plan that out first so we know what software we need, what hardware we need, and how we're going to approach it. And then what we're going to do is we're going to get into Visual Studio with C#, and we're going to see how we can get the time and date, where we're going to get the outside temperature, how often we're going to update, where we're going to get the inside temperature, how often we're going to update, and that kind of thing. So let's start out. And let's take a look at some things we're going to have to consider when we design this before we jump in and start coding. Now, again, I know a lot of people are going to jump off and say, no, I'm just going to start coding. That's up to you, but I guarantee you, you will probably make a mess and you'll come back and have to start all over. So I think it's worth the time to go through and just at least give some thought to how you're going to approach it. So as you can see from the application, we've got right here, we've got in bold, we've got the date and we've got the time, and you can see it's updating every second. Okay, so to do this, it's going to be fairly straightforward. A while back, I did a video on the C# date time functionality, so I encourage you to take a look at that. So we're just going to use that. It's fairly straightforward. And then we're probably going to need a system timer to update this every second. So we're going to have to know about that. But again, that's going to be pretty straightforward. Now, the next thing we're going to need is outside temperature. Now, you may think, well, it's just a number. It should be easy. Well, not so quick. Where are you going to get outside temperature? Well, you've got a bunch of choices. And for example, you can get a device like this. And this is something I bought a long time ago. It's an AccuRite digital indoor-outdoor thermometer. It's got a little sensor that you hang outside, and it gives you this outdoor temperature. And it also has a sensor inside this box that measures indoor temperature. Reasonably accurate, not totally accurate, but it's close enough. Unfortunately, in my case, that sensor died, and you can see it defaults to 32 degrees F for some reason, when actually it's like 60 degrees out or 70. But the challenge is, how are you going to get that data into your C# application? Not too easy. The sensor has communication, but it's pretty much proprietary to this box, and I don't think there's a way to grab it and bring it into your computer. Now, you can also buy a device like this that will connect to your smartphone, and you have an app that will chart the data if you want. You can access it via the phone, but then again, how are you going to get that to your desktop? We're going to be using a C# Windows Forms application on our desktop. How are you going to get that? And then you got to spend money on the device. So, you know, you got to figure out, you know, what are you going to get a phone app, and how are you going to put it onto your computer and that kind of thing. So buying a sensor, I'm not too thrilled about the idea. I think we need to look for another way. So what about from the internet? When you think about it, it's only one number, right? You update it every 5, 10, 20 minutes, whatever. You just need a number. This is nothing fancy. So maybe we can get it from the internet. Well, you got to figure out where. There must be places that give you open source temperature weather data, right? But where? So you got to find a place, and is it going to cost? You may find out, and you probably will find out, if you look at some websites that give you access to data where you can use an API and you can grab the data from your C# application, it may cost you. A lot of them have for pay services, but luckily some of them have free services as long as you don't try to access them too often. So you got to be thinking about where you're going to get the data, how much it's going to cost, and also proximity. You don't want data that is from a site that is 200 miles away from where you are, right? You want to have something that you can pretty much rely on being fairly accurate. And if you ever look at temperature data, geographical temperature data from a weather map, you'll notice that even within like 20 miles, the temperatures can be plus or minus 5 degrees, something like that. So if you're concerned about accuracy, you may want something, find out a source that you can verify is fairly close to you. And then again, how accurate is the source? I mean, it's maybe some guy with a weather station in his house, but is it accurate data? So it'd be nice to have something where you can verify whether it's accurate. And then if we're going to grab the data and put it in our C# application, what about new languages? We're going to have to learn how to do Java or Python or something to grab data from the website. To use an API. So do you want to do that? We're going to end up doing that, and we're going to grab from the internet and do some API stuff and see how to do it. It's relatively complicated for a simple one number every 10 minutes. And the other thing is update interval. These websites don't update every minute in general. So if you're going to have your C# application updating every 10 seconds, I think you're going to be disappointed, because as you can see here in this app, what I'm doing is I am checking, as I grab data from the web, I'm checking how long has it been since that number, the temperature number, has changed. And it turns out the site I'm getting it from updates only every 10 minutes. So that knowledge will help you decide how often you have to request data from the web. And you need things like threading. What do you need to be able to do this? If it's only every 10 minutes, you can make it a little bit less complicated. And then we talked about threading. Do we need to have this threaded? I mean, usually, like if you want the window to be accessible while it's grabbing data, do we need to do threading? In our case, we're going to use threading only because it's fairly straightforward. Do you need it? Probably not. Again, it's 10-minute updates. Does it really matter? But anyway, that's things to consider. So again, we're going to use some internet APIs. We're going to design our update intervals, and we're going to do some threading. Now, what about the indoor temperature? How are you going to get indoor temperature? Again, you've got this device here that measures indoor temperature, but you can't hook it up to your computer. What we're going to do, I'm a big fan of the Arduino, the Nano, very inexpensive, and it's a very useful device. So what we're going to do is we're going to use an Arduino Nano with like a $5 temperature sensor that's very accurate. It's called an MCP 9808. And we're going to use that through a USB port on our desktop and just grab data from the Arduino every 5 minutes or so. And you can see I've got here, I've got the inside temperature, and I'm giving the countdown to when the next update is. And we're going to update this every 5 minutes. And I'm also measuring how long it takes to send a request to the Arduino and get the number back. And it always comes out to about a little over 1.2 seconds. So that's good information to know when we design this, what we need to do. So again, it's going to be a COM port. We're going to have to know how to do a COM port to the Arduino. And I've done other videos previously about data acquisition with the Arduino that tell us how to set up the Arduino and your C# application to grab data from the COM port. And then the update interval. How often are we going to update the inside temperature from the Arduino? When is the data available from the Arduino? We're going to have to set that up. And are we going to request the data? Down here you can see you can either request the data from the Arduino, send a request, or just have the Arduino send it every fixed number of minutes, like every 1 minute or 5 minutes. So we got to decide, are we going to do it by request or timed? And then we're going to do threading. Is it worth it, or does it really not matter? So we got to think about that. And then the last thing we're going to do is we're going to save to CSV. Because again, I want to be able to plot this. I want to chart it in Excel and have nice charts like this where we can look at the actual numbers. Now here's another example of I'm using this application to write it to CSV in Excel, and this is like a 10-day period where I'm measuring the indoor temperature, which is the blue, and the outdoor, which is the orange, and we can see what the temperature trends are every 5 minutes for the last, in this case, 10 days. So it's good if you're interested in learning about temperatures and stuff like that. So to do that, we're going to have to save to, we're going to use the CSV. Again, you can also, there are some open source software libraries out there to do Excel, very complex Excel specific stuff, like save to an Excel file. But we're going to do a CSV. We don't have a lot of data. It's basically time, temperature, outside temperature, inside. And we're just going to plot it in the CSV, and you can drag and drop that into Excel, and it works straight away. So CSV helper, we've talked before, a number of videos I've got about using CSVs with C# and saving to CSV, and we use, generally I like to use CSV helper, which is a free open source library for CSVs. And then we got to figure out how often are we going to send this data to a file. We're going to log it, but how are we going to do it? Are we going to do it every time you grab every 5 minutes, say you grab data from the Arduino. Are we going to append it to the existing file? Are we going to overwrite it? What if we shut this down? What if our computer shuts down? How are we going to respond when we start it up again? We don't want to lose the old data, so we're going to have to be thinking about how we're going to do this Excel file on our disk. And then are we going to do threading? And then what data are we going to save? What I'm doing right now is I'm just saving the time and date, and then the outside and inside temperature. But you can save whatever data you want. You can get more data from the website on, whether it's what the wind speed is and all that kind of stuff. So you got to be thinking about if you want to add to this and put this into your CSV. And like I said before, we're going to append the file. We're going to just overwrite it each 5 minutes. We're going to overwrite the file and just add to it. And then we have to figure out when we do a CSV, we're going to have time and date. You can see here it's going to be a time of day, day and date. We're going to have to save it out of our CSV in a format that Excel can read and chart. So we're going to have to be thinking about that. So these are the basic considerations that we're going to be discussing when we do this. And again, you can see we're going to be covering quite a bit of stuff, which is, basically they're just a few numbers, but to do this is going to take some thought and some preparation. So what we're going to do in the next one is we're going to start looking at the app that I've developed, and we're going to go through it, and we're going to look at, first of all, the inside temperature, how we did that with the Arduino, and then the outside temperature, and then we're going to look at the CSV, how we save that and make CSV files, and then how we drag and drop into Excel and get this real quick. So anyway, I encourage you, if you like any of these videos and think they're helpful, please hit the like button and subscribe, and hit the bell notifications, all the things you're supposed to do to support people who give you free videos. And again, more importantly, if you think any of your friends or people you know or people in forums would like these and find them helpful, please direct them here, so we'll have a little bit more encouragement to continue doing these free videos. So anyway, hope that helps. Take care and have a really good day. Thanks.